Assalamu alaikum. Today we'll solve paper 2, unit 2 for Person Edexcel International GCSE or Edexcel Modular exam unit 2. Let's start with question 1. Question 1 says, this question is about elements in group 1 of the periodic table. The box gives some of the elements in group 1, cesium, francium, lithium, potassium, sodium. Select an element from the box to answer these questions. First one, give the element in period 6. Let's go to the periodic table. Period 1, remember that period 1 containing hydrogen and helium. So, lithium in period 2, 2, 3, 4, 5, period 6 containing cesium. So we have to write cesium, one of these elements of group 1. So let's write here cesium. Next question, state which element has ion that give a yellow color in frame test. In frame test, yellow color for sodium. Sodium gives yellow color or even golden yellow color. Next question, describe an experiment to provide evidence that the element rubidium could be in group 1. One of the properties of group 1 elements that when react with water, it gives hydrogen gas which make fizzing. So we can say that add rubidium to water, it will give fizzing, or we can say it will burn with a colored frame. Next question, the table shows the densities of some of the elements from group 1, this group. The density of potassium is not shown. Remember that potassium is in between lithium and cesium. If you back to the periodic table, you will find that lithium, cesium, and the potassium is exactly in between both of them. So first part of question, in question C, he just asks to plot a bar chart to show the densities of cesium and lithium. Density is one of them 0.5 and the other one is 1.9, and we have 1, 2, 3, 4 lines, so we can write it as 0.5, 1, 1.5, and 2. One of them is 1.9. 1.9 means right here for cesium. So we can draw it. Let's make a line. That's for cesium. For lithium, we can draw another line. Lithium at 0.5. So we can draw it right here. 0.5. Let's choose another color. For lithium. So this is considered as bar chart for lithium and cesium. Estimate a value for the density of potassium. As we mentioned, potassium is in between these two values. In between 0.5 and 1.9, we can use 0.9. We can use 0.8 to 1.6, any value between these two values. Even 0.8 is correct, 1.6 is considered also correct. So you can get any value between these two values. That's for question 1. Question 2. Sodium chloride NaCl is an ionic compound. The diagram represents the structure of sodium chloride. State why this structure prevents sodium chloride from conducting electricity. Remember that sodium chloride in solid state or any ionic compound in solid state not conduct electricity. Why? because ions are not free to move. Ions are not free to move. Next question, magnesium sulfide is MgS is a different ionic compound. Complete the diagram to show the structure of magnesium sulfide. Magnesium ion positive 2, so sulfide ion must be negative 2 to cancel each other and to be neutral. So we can write S minus 2 in H empty space, like this. Next question, explain why magnesium sulfide has higher melting point than sodium chloride. This question is related to higher level, but if you understand the concept, you will find the answer. Ions in magnesium sulfide have greater charge, positive 2 and negative 2, while in sodium chloride, positive 1 and negative 1. So attraction between ions will be stronger. So we can write that ions in magnesium sulfide have a greater charge, and this part is also related to AS level, and we discuss it in our course so that you will be able to solve this question. So stronger attraction between ions. Next question, B. The diagram shows the apparatus used for electricity or electrolysis of a concentrated, remember that, concentrated aqueous solution of sodium chloride. Aqueous solution of sodium chloride containing sodium ion, chloride ion, hydroxide ion from water, and hydrogen ion also from water. When he mentioned concentrated solution, so chlorine is formed because Cl is more concentrated or more ions of Cl than hydroxide, and in case of sodium, sodium is considered as reactive metal, so the less reactive positive ion will be hydrogen, so hydrogen will be discharged, hydrogen ion will be discharged. Hydrogen ion positively charged, so hydrogen gas will form right here on the negative terminal, and chlorine coming from chloride negative ion will deposited right here. So if he asks us, and we solve this question right now, gas Y will be hydrogen, and the gas X will be chlorine. So he asks about name. We will write gas X chlorine, don't write formula, just write name, and gas Y hydrogen gas. Gives a half equation for the reaction at the negative electrode. At the negative electrode, hydrogen is formed, so we can write 2 hydrogen ions plus 2 electrons gives H2. That's for question 2. Question 3, the diagrams show the structure of ice and the structure of a type of carbon. Ice and the carbon, as you can see, intermolecular forces between particles and covalent bond, intermolecular forces between particles right here and covalent bond right here, but in case of carbon form, which is diamond, covalent bond only exists, no intermolecular forces in carbon forms or whatever diamond. So which type of carbon is shown in the diagram? We mention now diamond. Both structures in the diagram have covalent bonds. Describe covalent bonding between two atoms, refer to electrons and the nuclei in your answer. So he gave you a hint. Just you have to mention nuclei and the electrons. It's a bond. Bond described as electrostatic attraction. Any description of bond must include electrostatic attraction. But in case of covalent bond, electrostatic attraction between shared pair of electron and the nuclei. In case of ionic bond, electrostatic attraction between oppositely charged ions, positive ion and negative ion. In case of metallic bond, electrostatic attraction between positively charged cations and delocalized electron. So he asking now about covalent bond. So electrostatic attraction between shared pair of electrons and nuclei of bonded atoms, or we just mention nuclei and get the mark. Next question, give one physical property that would be similar for ice and for this type of carbon. This type of carbon is considered as diamond, so it's transparent. For example, it's hard, but I prefer to write both of them does not conduct electricity. Remember that graphite, the other form of carbon, conduct electricity. Explain why ice has a much lower melting point than this type of carbon. Remember that this type of carbon, or whatever graphite, diamond or graphite, both of them considered as giant molecules, so they have very high melting point. But any other simple covalent compound will have lower melting point. Why? Because in case of simple molecule, it contains weak intermolecular forces, require less energy to break. But in case of giant covalent compound, or whatever giant covalent element like graphite or diamond, it contains strong covalent bond, requires high energy to break. So we can write that ice is a simple molecular structure with, as we just mentioned, weak intermolecular forces while carbon is a giant structure with many strong covalent bonds between atoms. The question is 5 marks, so we have to mention the energy. So we can say the energy to overcome forces in ice is less than in carbon. Now we get the 5 marks. Next question or next part, state a physical test to show that a sample of ice is pure water. To check purity, check the boiling point. So we can heat the ice to boil, and the boiling point will be 100 degrees Celsius. That's for question 3. Question 4. This question is about rates of reaction. The diagram shows a container with particles of a gas and particles of a solid. As you can see, particles of a gas 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and particles of a solid just 2. Which diagram shows a change that increases the rate of reaction? If you check the 4 choices, you will find that particles of a solid only changed. Changed to what? Change by changing particle size and surface area. Decreasing particle size and increasing surface area, both of them related to each other. By decreasing particle size, you increase surface area. This increases the rate of reaction. Decreasing particle size and increasing surface area exists in choice B. Next one, which diagram shows a change that decreases the rate of reaction? If you want to decrease the rate of reaction, you have to decrease the collision rate. To decrease the collision rates, you will choose this one. This one will have lower collision rate as the volume of the container is increased, so less collisions per unit time. So the correct answer is D. Next question. A teacher investigates the effect of temperature on the rate of reaction between dilute acid and a metal. The teacher warms the acid and adds the metal. The reaction between the acid and the metal produces a gas, which is corrected. The teacher records the volume of gas every 10 seconds until no further change in volume. The teacher uses 3 temperatures, 25, 35, and 45 degrees Celsius. The graph shows the teacher results for the two temperatures, temperature 1 and temperature 2. He mentions that temperature 1 is 35. Temperature 1 is 35. Temperature 1 is the solid line. This one for temperature 1. So, temperature 2. Let's check temperature 2. Using the information from the graph, explain whether temperature 2 is 25 or 45. As you can see, the curve for temperature 2 is less steep. This means slower. Slower, this means lower temperature. 25, not 45, because the curve is less steep. We can write it, graph is less steep. So temperature is lower. So it must be 25 degrees Celsius. Next question, for temperature 1, draw a tangent on the graph at 30 seconds. At 30 seconds, temperature 1. So we have to write a tangent right here. Check this one. I'll try to draw it for you. It's something like this, but you have to draw it by a ruler. Also, it must be tangent to this point, like this. I'll try again. Remember that I draw it by my hand, but you can draw it by a ruler, and you will get slope from 120 to 36 right here, and from 0 to about 67. You will find it by drawing the tangent by a ruler. So you can get the slope 120 minus 36 over 67. The slope is 120 minus 36 over from 0 to 67 right here. So the correct answer will be 1.25 cubic centimeter per second. He mentions that approximately 1.3, but we found it 1.25, considered as correct answer. The teacher predicts 10 degrees Celsius increase in temperature. The rate of reaction will be double. Using the teacher's prediction, deduce the rate of reaction at 30 seconds. rate of reaction at 30 seconds when temperature is 65. So change in temperature 65 minus 35 is equal to 30 degrees Celsius. From where we get 35? From this one. We are talking about temperature 1, and he mentioned temperature 1 was 35. So 65 minus 35 equals 30 degrees Celsius, and for every increase of 10 degrees Celsius, the rate of reaction doubles. So the rate of reaction doubles 3 times. So rate doubles 3 times. This means 2 times 2 times 2, or we can say 2 power 3 is equal to 8. We just found the rate 1.25, multiplied 8 is equal to 10. So the rate of reaction will be 10 cubic centimeter per second. The teacher decides not to extend the temperature range of their investigation. One reason was for safety. Discuss the other reason why the investigation could not be extended to temperature 65 or to temperature -5. Remember that temperature 65 is considered as high temperature, so the reaction will be too fast. For 65, measurement will not be accurate, and the reaction will be too slow in case of -5 degrees Celsius, so the reaction will take too long to complete. So let's write this. So we'll write reaction is too fast at 65 degrees Celsius to take measurement accurately and the reaction is too slow at -5 degrees Celsius, so the reaction will take too long to complete. But the question is 4 marks question, so we need to write that most particles have high kinetic energy at 65 degrees Celsius and low kinetic energy at -5. degrees Celsius. We can also write that more frequent collisions at 65 degrees Celsius and less frequent collisions at -5 degrees Celsius. That's for question 4. Question 5. Propene C3H6 is used to produce polymers. C3H6 can be made from the thermal decomposition of C3H8. So C3H8 gives C3H6 plus H2. Calculate the maximum mass in gram of C3H6 that can be produced from 6,600,000 grams of C3H8. At the beginning, we have to calculate MR for both of them. MR for C3H8 is equal to 3 multiplied 12 plus 8 equal 44. MR for C3H6 will be 42. Then we have to calculate the number of moles of C3H8, then multiplied by MR of C3H6. So we have to divide the value, the mass, 1, 2, 3, 4, 5, divided by 44, and then the answer must be multiplied by 42 to get 6.3 multiplied 10 to the power 6 gram mass for propene. The diagram shows the structure of C3H6. C3H6 can undergo polymerization. Name this type of polymerization. This type of polymerization is called addition polymerization. Complete the diagram to show the 3 repeat units of the polymer. First, carbon containing 2 hydrogens, as you can see right here, 2 hydrogens. And the second one, CH3 and H. And we have to repeat it. 2 hydrogens right here, and CH3 and 1 H. Sorry. 2 hydrogens, CH3 and 1 H. Next question. Burning is one method that could be used to dispose of this polymer. Burning produces carbon dioxide. Explain one problem this causes. Global warming. And global warming, or whatever we can say that contribute to climate change. Remember that the question is 2 marks question, so global warming only will give just 1 mark. Another method of disposal of polymer is burial in a landfill site. State one problem with this method of disposal. Plastic is considered as non-biodegradable, so it will remain for a long time, make shortage of land, or even remain in environment for very long time. This for question 5. Question 6. This question is about the reactions of ethanol and ethanoic acid. Ethanol reacts with potassium dichromate 6 to form ethanoic acid. Name other reagent needed for this reaction. We need acid catalyst. We can write phosphoric acid, or we can write sulfuric acid. One of them. State the color change that occurs when ethanol reacts with potassium dichromate 6. Color change from orange to green. Ethanoic acid reacts with sodium carbonate. Complete the chemical equation for this reaction. It gives sodium salt, 2CH3 COONA, plus carbon dioxide plus water. State 2 observation for this reaction. Fizzing and he told us that ethanoic acid reacts with solid sodium carbonate. So we can write that solid sodium carbonate disappears. Part C. A student prepares the ester ethyl ethanoate by reacting ethanol with ethanoic acid. This is the student's method. Mix equal amounts of ethanol and ethanoic acid in a boiling tube. Add a few drops of concentrated sulfuric acid. Place the boiling point in a hot water bath for several minutes. State the role of sulfuric acid in this reaction. As we just mentioned before, it's considered as catalyst, and the catalyst, you know that it speeds up the reaction. State why the student heats the mixture in a water bath instead of directly with a Bunsen burner flame, because ethanol is flammable. State how the student would know that ethyl ethanoate has been formed from its frothy smell. That's for question 6. Question 7. Oxygen, O2, is one of the gases in the Earth's atmosphere. Describe the test for oxygen gas. It rewrites a growing sprint. Write dot and cross diagram for a marker of oxygen. We can draw it like this. O and O, double bond, and 2 pairs right here, and 2 other pairs right here. Remember to check that each oxygen atom surrounded by 8 electrons and 6 electrons for each atom originally. Oxygen makes up about 21% of dry air. A student uses this apparatus in an experiment to determine the percentage of oxygen in a sample of dry air. As you can see, the apparatus. At the start of the experiment, the air in the apparatus has total volume 230 cubic centimeter. Total volume of air 230 cubic centimeter. At the start of the experiment, the reading on gas syringe was 100, but decreases as all of the oxygen reacts with iron. You can see that wet iron fairing right here. Determine the final reading of the gas syringe if the dry air contains 21% of oxygen. Remember that initial volume was 230 cubic centimeter. Multiplied 21% is equal to 48.3. So the volume of air decreased by 48.3. So we can write that 100, the reading of the gas syringe, minus 48.3 is equal to 51.7%. He asks to give 2 significant figures, so we can write 52%. Remember that working is not required, so if you write 52%, the final answer you will get the 3 marks. Iron fairing reacts with oxygen. Iron fairing, we can write Fe, reacts with oxygen, O2, to give Fe2O3. We need to balance this equation, 3 oxygen right here, so you have to multiply by 2 to get even number, because oxygen is even right here. 2 multiplied 3 oxygen gives 6, so we can write 3 here. 2 multiplied 2 equal 4, so we can write 4 here. Fe3O4 is the formula of a different iron oxide. Fe3O4 contains 2 most common ions of iron. You know that most common ions of iron, Fe positive 2 and Fe positive 3. Complete the table by writing how many of each type of ion are found in Fe3O4. Remember that for oxygen, minus 2 multiplied 4 is equal to minus 8. And we have 2 and 3. If we use 2 from iron 2, it will give 2 multiplied 2 equal 4, plus 3 equals 7. But we want 8. So plus 2, only 1, and plus 3, we will use 2 of them. So Fe plus 2, only 1. Fe plus 3, we'll use 2 of them, and no 4 or 5. That's for question 7. Question 8. This question is about the compound ammonium chloride NH4Cl. The reaction of ammonia and hydrogen chloride produces ammonium chloride. Ammonia plus hydrogen chloride gives ammonium chloride. When ammonium chloride is warmed in a test tube, a mixture of ammonia and hydrogen chloride is produced. Ammonium chloride, by decomposition, gives ammonia and hydrogen chloride by heating. State how the mixture of ammonia and ammonium and hydrogen chloride can be changed back to ammonium chloride. He mentioned here warmed, heated, so cool the mixture to get back. Give a chemical equation including state sample to show that this reaction is reversible. Ammonia gas plus HCl gas, reversible arrow, ammonium chloride solid. 1 mark for reversible arrow and 1 mark for state sample. A student tests an unknown compound Z to see if it may be ammonium chloride. The table shows the result of the test on ammonium chloride and compound Z. Frame test, no frame for ammonium chloride, and orange-red frame for compound Z. Orange-red frame, we are talking about calcium, but let's check. Dissolve the compound in water. When dissolve in water and add few drops of sodium hydroxide and warm the mixture and carry out test for ammonia, ammonium chloride will give positive test. So damp, red, litmus, damp means wet, paper turns blue, and no gas produced for compound Z. Dissolve the compound in water and add few drops of acidified silver nitrate solution for chloride. It gives white precipitate, but it gives yellow precipitate with iodide, and we mention here calcium. So complete the table, we did it. Second one, use the results in the table to deduce the formula of compound Z, calcium iodide. So we can write calcium iodide, CaI2. The student carried out further tests on each compound. The student's method: dissolve the compound in water, add a few drops of bromine. Remember that chlorine, bromine, iodine, or we can write chloro, bromo, iodo. So reactivity decrease down. So chlorine can replace bromine, but bromine cannot replace chlorine. Also bromine can replace iodide or whatever iodine, but not vice versa. Explain the observation that the student would make for ammonium chloride and compound Z. For ammonium chloride, bromine cannot displace chlorine, so we can say that no color change as bromine cannot displace chlorine from its compounds. For compound Z, we're talking about iodine, so solution turns brown as bromine displaces iodine from its compounds. Remember that bromine is more reactive than iodine. That's for question 8. Question 9. In industry, ethanol C2H5OH is produced using the reaction of ethene gas C2H4 with steam. The reaction is normally carried out in the presence of phosphoric acid catalyst using a specific temperature and pressure. The boxes give two conditions and possible values. For these conditions, draw one straight line from each condition suitable to a suitable value. Pressure 60 and temperature will be 300. Temperature in Celsius will be 300. The reaction profile diagram for uncatalyzed reaction is shown. Uncatalyzed reaction without catalyst. Explain how the reaction profile diagram would change when phosphoric acid is added to the reaction mixture. As you can see, if you add catalyst, it will make like this. So the peak of the curve would become lower. The peak, you want us to write it. So the peak of the curve would become lower because the activation energy is decreased. Lower activation energy. That is the rule of catalyst. A chemist investigates what happens when the reaction occurs in a sealed container. When the temperature is increased, the yield of ethanol decreases. As you check right here, the reaction is exothermic. Why the reaction is exothermic? Because products have less energy than reactant. So when temperature is increased, the yield of ethanol decreases. Explain why this happens. Use the information from the reaction profile diagram in your answer. The reaction is in equilibrium and the reaction profile shows that the reaction is exothermic. So the increase in temperature causes reaction to move towards the reactants. In an experiment, the percentage yield of ethanol C2H5OH is 5%. Percentage yield is 5%. Calculate the volume in cubic centimeter of ethene gas at RTB needed to produce 1.8 gram of ethanol. Let's write the equation at the beginning. C2H4 plus H2O reversible reaction gives C2H5OH. MR for ethanol is equal to 46. R for ethene. We just calculate number of moles of ethanol. Number of moles of ethanol will be 1.84 gram divided by 46. It will give 0.04. But take care, the percentage yield is 5%. So 100% gives only 5. So 0.04 coming from how much? By cross multiplication, we can get that 0.04 multiply 100 divided by 5, coming from 0.8 mole. So now we know the number of moles of C2H4, which is equal to 0.8 mole. Volume of C2H4 is equal to 0.8 multiplied 24,000, because he asking about volume in cubic centimeter. If in cubic decimeter, we mention 24 cubic decimeter. So volume of ethene will be 19,200. And this was the last question of our exam. It's not so hard as we heard before. It's normal exam. Also, we can solve it just by practice. Thanks for watching and wait for more videos. Goodbye and good luck.
As you observed during the exam that almost all questions are present in my study notes for students, and my students already trained for all these questions. Now this is your turn to join the course for O level and AS level.